and welcome back to another Hancock's VMware half hour. In this little mini series, we're talking about home labs, or specifically in this home lab, we are talking about this particular server here, which if you've been following this mini series, in part one, we discussed the Datto server. And how we can actually basically change the Datto BIOS and the Datto BMC for stock ASRock firmwares that are available. And if you can't find the SOC flash kit, then let me know in the description and we can sort you out with that. In part two, I showed you how to install VMware ESXi 8.03 hypervisor on that server. Where we're using Samsung NVMe M2.SSDs in the sockets on that server. In part three, I showed you how to update that server over the air to the latest and greatest 8.03D, which is the version of ESXi which fixes the security critical update, or the critical 0-day update that basically was spotted and came out on the 4th of March 2025. So in this episode today, and I've kept it a little bit secret, I did actually basically say to you that I was actually waiting for some crucial P3 Plus PCIe 4.0 NVMe M.2 SSDs from Amazon, and they've arrived, and we bobbed one of them in the server. And there's a reason why that I've picked the brand Crucial. It would appear that there are very few companies really in the world that are producing NVMe flash. One of those is Samsung, one of them is Micron. And in fact, Micron is the company behind Crucial, or it's Crucial by Micron. So if they manufacture the stuff, then it should be pretty good. And Crucial NVMe is a lot cheaper than Samsung, but both respectable brands. When I actually basically, of course, Crucial is owned by Micron, the foundry that actually produces the stuff. So, you know, they're not going to basically chuck their rubbish and sell it on to fangyang.com or whatever, and fangyang.com sell rubbish on Amazon or whatever it is. So for me, that's a choice to save a little bit of money in the lab. Samsung versus Crucial, Samsung Flash versus Micron Flash, much the same. Just that I suppose Samsung has a bigger marketing budget compared to Crucial, but Crucial have been around for donkey's years. You know, they've got their own Crucial website, mixing and matching memory for servers, and guarantee that it will work in your server. And it's sort of kind of, you know, I don't know, probably a third of the price of what vendor memory from HP or Dell is. Anyway, so we've bobbed, installed that memory in our server. And what I'm going to do, I'm going to log on to that server. And I'm going to show you that that stick actually exists in the server. So I'm just going to basically log into the HTML client. Let's just turn that off. Okay, so this is the server. This is the server that we installed in part 2 and updated in part 3. So 8 CPUs times Intel Xeon CPU D1541 at 2.1 gig. Memory currently is 48 gig. As I've said to you before, I think all the slots in this server at the moment are occupied. I think there's a couple of 8 gig DIMMs in there, and then I think a couple of 16s, I think. Anyway, the maximum amount of memory in this server is 128 gig, and I would have to replace all those DIMMs in there to put 32 gig DIMMs in all 4 slots to get it up to 128 gig. I haven't actually looked at the cost of what 32 gig DIMMs are for this server at the moment, but I can tell you now that 4 32 gig DIMMs are going to be more than I think I paid £59 for 1 TB Crucial P3 Plus NVMe M.2 SSD. So there is a reason that I've been keeping a little bit secret in this video, and I'm just going to restart the session. The keen-eyed amongst you will have noticed the command above. I'm going to explore memory tiering. Now, memory tiering is a tech preview at the moment. I don't think that it's actually released. It's actually been released there as production ready. But what memory tiering allows you to do, it allows you to use the storage on an NVMe stick. Now, you do have to dedicate an NVMe M.2 SSD device for memory tiering. And you can only allocate between 25 and 400%. So in my particular example, really using a 1 TB is probably a bit wasteful. I probably would have been better actually installing ESXi on the Crucial on the 1 TB, because the remaining portion of that would have been used as a data store, and then I could have used the Samsung, which is 500 gig, for our memory tiering NVMe M.2 SSD. But it doesn't matter, it's done now. Maybe I'll change it in the future when I've actually got some time. But anyway, so we've got a spare. If I just, as I promised, if I actually basically go to storage, and if I actually basically go to devices, then you may be able to see there that we've got a local NVMe disk T10.NVMe CT, which stands for Crucial, followed by its serial number, and it's a P3 PSD8. So that's the actual basic model. So that's our NVMe stick, which is actually installed in our server. Now, there are a few prerequisites for this, and one of those really is that you have a modern processor in your ESXi host. Now, we're lucky, and this is one of the other reasons why I think that the ASRock rack motherboard that we're using is an absolute cracker for this. It really is in the homelab. That we have a supported processor that can be used for memory tiering. It's the first processor, because it's a Broadwell, so it's the first processor basically that we can use for NVMe tiering, because we are having to use a specific CPU function. I think it's the VMware function, which is available basically in the Broadwell chip and later. Doesn't actually exist in any of the processors before that. So if you've got an older processor, unfortunately, you won't be able to use memory tiering. However, if you've got one of these ASRock rack motherboards, you can turn on memory tiering. And it's quite simple. So the first thing that we need to do, obviously, is we have to have an NVMe stick in our server that we are going to dedicate for our memory tier. So if we just actually basically go back to our server, if I basically just hit that, so we get a nice yellow of a grey. So you can currently see here that our server at the moment is 47.9 gig. Now, as I said to you before, that's actually quite small. And I want to build a server later on this host that's got 64 gig of RAM in it. And we wouldn't be able to accommodate that with 47.9 gigs. So just to demonstrate that memory tiering does work and it doesn't crash and burn, in the next video, I'm going to basically create a virtual machine with 64 gig so that we can actually basically see it operating on this host. But in the meantime, so I've got an SSH session open, and the first command that we're going to run, and I'll put these in the description so that you can copy them. So the first, tell you what I'll do, let's just turn off that so you can see this, and let me just basically boost the size of, there we go. Hopefully we can see that a little bit better. Just let me adjust this. There we go. So hopefully you can see that a little bit better, but I will put these in the description. So the first command we're going to use is quite simply ESXi space system space settings space kernel space set dash s space memory tiering, that's an uppercase M and that's an uppercase T, dash V true, uppercase true, followed by enter. It's not going to come back and turn around and say not supported or broken, doesn't work. If memory tiering is not actually turned on, then we're going to have to actually look at the VMware VM kernel logs to see what the problem is. So the next thing that we need to do, we need to obtain the device ID. So that's this big long thing here, because we need to actually basically create a tier device. So again, I'm going to use this big long command, copy, paste. So ESXi space system space tier device. This is the command we want to use. Space create space dash D followed by /VMFS / device / disks / followed by your actual device ID, and it has to be copied exactly, followed by enter. Okay, now it's telling me that the selected device already has an existing partition. Now that's because I've been experimenting with this and I've done it before. So tell you what we'll do. Let's just erase that partition so that we can actually basically create it. So I'm just going to select the device and I'm going to say clear partition table followed by yes. And hopefully basically then that's it. There's nothing on that now. That's a virgin NVMe M.2 SSD. So hopefully if I go back now and run that command again, it's not going basically to fail. It's just going to do it and it's not going to respond with any message. Okay, so there's our partition defined. If of course that you had been using that NVMe as vSAN caching tier, or VMFS data store, or it had some sort of NTFS or FAT32 partition on it, then you'd have to go through that exercise as well, because the ESXi command is not going to erase the device for you. It's expecting a virgin empty device. And then the next command is a command. I'll also basically put the PDF, because there is a PDF that has been released by Broadcom on this that you can read, and it's worth a read. So ESXi space system space settings space advanced space set dash O / mem uppercase M / tier NVMe PCT. So that's uppercase T there and an uppercase N, uppercase P dash I 400. Now that's a percentage. I can't quite get my head around this at the moment. I'm going to have to think about this, but this is 25 to 400%. 400% is the largest value, so I'm just going to go with 400 here in the lab. So I'm going to hit enter. So that's it. There's nothing more for me to do. So what I'm going to do, I'm going to turn back on our BMC connection. You can currently see at the moment basically that it says 47.9 gig. So I'm going to shut down and restart this. It's not going to take very long to restart here because we're not using SSD, we're not using USB, we are using NVMe, so it's quite fast to boot on this. And I'm basically going to do an F11 basically to restart, and hopefully we're not going to get any purple screen of deaths or pink screen of deaths. Our SSH session probably is going to end. Yeah, it went beep ended, so I'm going to get a big X out of that. System has halted, and basically we're going to wait for a restart and watch, because one of the things is actually basically quite interesting, and I've done this a few times. At first, when you watch ESXi boot for the first time after you've effectively turned on memory tiering, you sort of kind of think to yourself, oh, that's not worked, because the first thing that is shown is the memory's initialized, and that's the physical memory in the machine that's actually initialized. And it's only later on when it obviously loads that configuration that we've just done there, those 3 lines, enabling memory tiering, setting up a device that can be used, and then effectively giving it a 25 to 400% that it turns that on. And as you will see in this video here now, as we watch the BMC load, you will see the figure change from 47.9 gig to 200 and something gig. So if we're quiet, you won't hear that, because that's the fans in the server that are just initializing. So here we go, 47.9 gigabyte on our Intel Xeon CPU D1541 2.1 gig to be filled by an OEM. And if we watch carefully, you will see that it just flips over and changes to 200 something gig, hopefully, if all is working well and I've done everything that's needed to be done correctly. It definitely worked before, so I'm hoping that it works again. So ta-da! It's like magic, isn't it? So there you go. Just for a £59. Okay, I could have got one cheaper. I could have bought a honky tonk NVMe stick off Amazon for 32 quid. I could have got a Samsung one for £49. I could have got a 500 gig one, but I went for a 1 terabyte. But anyway, so for £59, I've increased the memory in our lab server here, our home lab, by almost 200 gig. By just installing an NVMe stick in the server and enable memory tiering. Brilliant, isn't it? Absolutely brilliant. I think that for home labs, and this has been around for about 12 months. You know, I really haven't had chance to visit it because I've been sort of kind of so busy. And I've been wanting to do a video about this for a very, very long time. And I thought that with home labs on a budget, and you know, sort of kind of, you know, suggesting to people that if you want to get a home lab, get yourselves on a Datto server, get yourselves on get yourself one of these AX Rock Mac motherboards, and for very little money you can really have a sizable home lab by using memory tiering. So that's all there is for this particular video this evening. You know, 17 minutes in, that's not too bad for a Hancock's VMware half hour. Anyway, so all we've done is install NVMe M.2 SSD in our server. It's not on the Harvard compatibility list. It's cheap as chips. You know, we've started the host up. Of course, prerequisites, you know, we need to have a Broadwell CPU or later. We need to be running really the latest version of ESXi 8.03. I can't remember specifically what version that this appeared in. It could be 8.03. I'll have a little look and I'll put it in the description. I'll put these commands in the description as well. If you like this video, then give me a thumbs up. If you don't like this video, then don't like it and just give me a thumbs down. But whatever you do, then, you know, please subscribe and come back for the next couple of videos where we're going to be using our home lab server. I'm going to create a Windows, maybe we'll do a Windows 2025 virtual machine on it, and we'll give it 64 gig. And there's a reason for that, and I'm keeping that back at the moment. I'm keeping that a little bit secret, but I actually basically want to go back. I'm jumping back to another series that we started that we're going to have a little look at on this server as well, that I did promise. So if you've been following all these videos, then you may have an idea what the next video is going to be. But it won't be the next video, it'll be the video after that. But you may get an idea. We're going, you know, we're jumping around all over the place here. You know, we're doing home labs. You know, we're doing 7.0 series, 8.0 series, and you know, and we've touched a bit on Synology that we'll probably go back to. We've jumped around and looked at, you know, Veeam backup and replication. So, you know, I'm trying to cover all bases broadly in, you know, VMware land. So again, if you've got any suggestions for any videos that you'd like to see, then drop them in the description. If you've got any questions, then drop them in the description as well. I'm going to go off now, and I'm going to get a nose bag, and I'm going to get a drink of coffee and a drink of Pepsi Max, I think. So once again, thanks very much for watching Hancock's VMware half hour, and I'll see you again. Cheerio and good night. Goodbye.